Okay, this is the continuation of the notes for Algebra 2, Section 9.3. And in this section, I've got a bunch of pre-worked examples that kind of help you with the homework. So pay special attention to the instructions. These instructions will match some of the instructions maybe in your homework. So if you're going to find points of discontinuity, you set the bottom equal to 0 and factor and solve. So there's a point of discontinuity at 2/3 and another one at x equals -4. Now later I'm going to ask you to decide whether those are vertical asymptotes or holes, and that'll be the next section. But here you're just finding points of discontinuity. So once again, you take the bottom and set it equal to 0 and solve. And so you'd find either a vertical asymptote or a hole at these two locations, one on the right at x equals 2√5 and the other at the left at x equals -2√5. So here's another one, and when you set this one equal to 0, it eventually leads to something that unless you're allowed to use I, and we're not using I, these are real numbers, can't be solved. There's no real solution, so there are no points of discontinuity. All right, this one here uses a formula that I'm not sure I always cover every year, but anyway, it's called the sum of cubes, and it's x plus 3 times x squared minus 3x plus 9. Now the first one, and I'll explain that to you separately if you haven't seen that yet in the particular year that you're learning these notes. X minus x plus 3 leads to this point of discontinuity, and the other one leads to, through the quadratic formula, something with I in it. So there's no points of discontinuity there. Okay, in example 14, we have a different set of instructions. We're supposed to not only find the points of discontinuity, it doesn't even tell us that, but you have to do that first, and you have to decide whether they're vertical asymptotes or holes. So you can see that I've already got this first one factored, which leads us immediately to these points of discontinuity, 5, -4, and -3. And the one that will cancel out both the top and the bottom, if you put -4 in, it zeroes out the bottom and the top. That's how you figure out it's a hole. It also cancels. You can see that factor shows up in both, so that's what's going to tell you that it's a hole. Okay, this next one here, I factored the top and factored the bottom. You can use the star method if it helps you. 2 points of discontinuity. The one that cancels is a hole. And so you got a hole at 3/2, and you got a vertical asymptote on this graph at x equals -8. Okay, the last 3 problems on this graph, or in this page, excuse me, are dealing with finding horizontal asymptotes. And there's 3 cases. I think I covered 2 of them here, and maybe the next one will be on the next page. I'm not sure. But if the degree of the bottom, this one's quadratic, is bigger than the degree of the top, or you could say that the degree of the top is less than the degree of the bottom, then you always get y equals 0 for your horizontal asymptote. That's an automatic. If they're matching degrees, these are both quadratic, then the the coefficient of the highest degree term is 10, and the same thing down here, there's 2. You just take 10 over 2 and get 5, and that's your horizontal asymptote. And that does it for page 5 of the notes.